Look at the photo of this galaxy. Can you tell me where up and down are? If we look at the photo for a second, the answer is probably that there are stars above and below. The problem is that those stars could be in the background or in the front, not necessarily above and below. But if we rotate the photo 90 degrees, what is up and down now? As you can see, defining the up and down of a galaxy is not so simple. Fortunately, in this episode, you will learn how these concepts are defined, and you will discover what is above and below our galaxy, the Milky Way. Let's get started. Our galaxy, the Milky Way, is not a lonely island in a lost vacuum. It is part of a much more complex and fascinating structure known as the Local Group. Around us, small satellite galaxies orbit and act as constant escorts, such as the large and small Magellantic Clouds, which are visible from Earth's southern hemisphere. However, the real heavyweight in our neighborhood is the Andromeda Galaxy, also known as M31. This giant spiral lies at a colossal distance of about 2.5 million light-years from us, roughly 14.7 quintillion miles. To give you the scale of our home, the farthest spacecraft we've ever sent into space, Voyager 1, has traveled for more than 45 years and has barely covered 15 billion miles. That's just 0.00001% of the distance needed to reach our nearest galactic neighbor. These dwarf galaxies are slowly being warped by the Milky Way's gravity, in a process that could eventually culminate in their full absorption. If we broaden our perspective even further, the Local Group is part of a much larger structure called the Laniakea supercluster, a vast region containing about 100,000 galaxies and spanning more than 500 million light-years, or about 2.9 sextillion miles. Within this gigantic structure, our galaxy occupies a relatively peripheral position, far from the densest centers. The Milky Way is not at the center of anything in particular. Rather, we are part of an immense cosmic web, where galaxies are grouped into filaments and clusters separated by huge voids. Hey Curious Squad, before moving on, be sure to subscribe to our channel and click on the notification bell so you don't miss out on our daily videos. The Milky Way rotates not as a solid object, but as a complex gravitational system in which billions of stars orbit a common center. That center is dominated by a supermassive black hole known as Sagittarius A star, with a mass equivalent to about 4 million suns. Our Sun, along with the entire solar system, orbits this center at a distance of about 26,000 light-years, moving at a speed of around 514,000 miles per hour. At this rate, it takes about 225 million years to complete a single orbit. Since dinosaurs appeared on Earth, the solar system has not even completed one full lap around the galaxy. There's also a translational movement on an intergalactic scale. The Milky Way moves through deep space, but not like a bullet pointing forward. In reality, our galaxy moves sideways, much like a frisbee thrown through the air. This movement carries us at approximately 1.3 million miles per hour relative to the cosmic microwave background. While we feel perfectly still on Earth, we are engaged in a threefold dance. We rotate with our planet, we orbit our Sun, and our entire galaxy glides sideways through the intergalactic ocean. However, we cannot use the galaxy's translational motion as a reference to define up and down. This motion is neither fixed nor universal, and it changes over millions of years due to gravitational interactions with other structures. So how do we define up or down in a place without ground, without sky, and without reference points? The answer lies in a reference system based on the structure of the galaxy itself, specifically the galactic plane. Our Sun moves around the center of the Milky Way at about 514,000 miles per hour, completing one orbit every 225 million years. The Earth's orbital plane, the ecliptic, is tilted about 60 degrees with respect to the galactic plane. This means the solar system is tilted within the Milky Way, like a slightly twisted disk inside a much larger one. Instead of defining up and down by motion, which is arbitrary and changes over time, astronomers use something far more stable, the galactic plane itself. The Milky Way is disc-shaped with a thickness of about 1,000 light-years and a diameter of about 100,000 light-years. From this plane, the galactic coordinate system is defined. Galactic north is a direction perpendicular to the disk. Galactic south is the opposite direction. Here's a detail worth noting. Our solar system is not exactly at the center of the galactic plane. It is slightly offset, approximately 65 light-years above the midplane. Technically, we are already a little above the center of the Milky Way. Now that we know above points toward the galactic North Pole, we can look in that direction. The reference constellation is Coma Berenices, a seemingly inconspicuous region that actually points toward some of the most massive structures in the nearby universe. If you could travel perpendicularly away from the galactic plane northward, the first thing you would notice is the Milky Way's disk receding into the distance. Dense clouds of gas, dust, and stars disperse rapidly, and within thousands of light years, you would enter the galactic halo. From there, the galaxy would appear as a gigantic spiral disk beneath you, like a luminous city seen from a helicopter at night. Beyond the halo, the real intergalactic journey begins. One of the first large structures we encounter is the Virgo Cluster, about 54 million light-years away. A vast concentration of galaxies containing Virgo A, a supermassive elliptical galaxy whose gravity dominates the entire region. Continuing much farther, we reach the Coma Cluster, located about 321 million light-years away. This colossus contains more than 1,000 galaxies and represents one of the densest regions in the nearby universe. Now, if we completely reverse direction and look below the Milky Way, toward the galactic South Pole, the panorama changes radically. Orient yourself toward the constellation Sculptor. One of the most prominent objects in this direction is NGC 253, the Silver Coin Galaxy, located about 11.4 million light-years away, one of the closest galaxies outside our local group. But beyond these isolated structures, the galactic south is dominated by something far more unsettling, the Sculptor Void, a vast region with an extremely low density of galaxies, a cosmic desert stretching for tens of millions of light-years. Unlike the galactic north, where we find dense, massive clusters, here emptiness predominates. It's like comparing a densely populated city to an almost endless desert. In summary, above the Milky Way, following the galactic North Pole, we find dense galaxy-rich regions, the Virgo and Coma clusters. Below the galactic South Pole, we enter a much emptier region, dominated by the Sculptor Void. The Milky Way sits between two completely different cosmic realities. Although our galaxy moves through the void like a tilted disk, it does not do so aimlessly. It is heading towards a series of encounters that will forever transform its structure. The first inevitable event is the collision with the Andromeda galaxy, currently about 2.5 million light-years from us. Andromeda is not moving away like most galaxies. It is coming straight toward us at a speed of about 68.5 miles per second. This epic encounter will occur in about 4 billion years. It will not be a destructive collision between solid objects, but a majestic, gravitational dance in which both galaxies cross paths and merge to form a new colossal elliptical galaxy, nicknamed by scientists Milkomeda. However, even after this new mega-galaxy stabilizes, the journey continues. There is an even more imposing force dominating our movement on a larger scale, the Great Attractor. This is a massive gravitational anomaly located about 250 million light-years from Earth. The Great Attractor is also so powerful that it is pulling hundreds of thousands of galaxies, including our own, toward its center, like an invisible cosmic sinkhole. We are moving toward that point at approximately 1.3 million miles per hour, relative to the cosmic background. This is the ultimate destination of our journey through the cosmos, an initial metamorphosis with our nearest neighbor, and a final drift into the heart of a megastructure that still challenges our understanding of physics. Now you know what is above and below the Milky Way, but there is still one question worth asking. Exactly where inside the galaxy are we? If you had to send coordinates to someone to find Earth from across the cosmos, what would you say? Watch this next. Where are we in the Milky Way?